Hello. So you asked me this question, and I can't teach Dr. Chon method because I don't know how to do that. But Dr. Chon method is also good and correct. If you can follow her method, then do her method because she's the one checking your exam paper. So it's good to follow her method. But if it is not clear, maybe you can follow this method. So we have 2 mole of NH3, 3 mole of hydrogen, and 1 mole of nitrogen. And as always, you have to check the reaction, and you can see that they are all in gaseous state and is also a reversible reaction. So it's good to do the Kc calculation right now. And now we can do the ICE because if you look at the question, it say that the equilibrium concentration is only for this one, NH3. The equilibrium concentration is given only for NH3. You don't know the equilibrium concentration for H2 and N2. So that is when you have to do the ICE. Anyway, so what we start is we have to look at the initial concentration first. So this one is initial concentration. In the question, you can see that 1 mole of NH3 and 0.40 mole of N2 are added. So these are initial concentrations. You write it out and make sure they are mole. If you want to calculate in molar concentration, make sure that you have changed it to molar concentration. All right. So you can either change it into molar concentration in the beginning or only at the end of the ICE. For me, I changed to molar concentration at the end of the ICE. But right now, I'm going to use mole. So as I have mentioned, 1 mole of NH3 is added, 0.40 mole of N2 is added. In that moment, I haven't done anything yet. I am just writing down the information, and now I'm going to calculate the change. So how much of each reactant and each product has changed before the equilibrium is reached. So when it comes to change, it is always negative for reactants. So whatever is on the left side of this arrow, you put it negative. So I put negative, and then I put positive for the products, and then I put positive for another product. So plus, plus, minus. And then after that, you have to look at the mole. So here we have 2 mole of NH3. That's why it's a minus 2X. And we have 3 mole of H2 plus 3X, 1 mole of N2 plus X. So when you calculate the equilibrium, you have to combine the initial and change. But here, because reactant has negative, when you calculate the equilibrium concentration for NH3, it becomes 1 minus 28 is equal to 0.78. So it's like that, right? So 1 minus 2 is equal to 0.78, and then you can start calculating the A's, and you got the A's. So why you need A's? Because you need to calculate the equilibrium concentration for H2 and N2. And here you have A's. So when you want to calculate the equilibrium concentration for H2, you just substitute this value into this 3A's. So here 3A's is equal to 0.33. And then this one as well, now I mentioned that if you want to find the equilibrium concentration, you have to combine this, combine initial and the change. So in order to get the equilibrium concentration of N2, 0.40 plus A's is equal to 0.4 plus 0.11. A's value is 0.11. So 0.11, and then you get 0.51. And now I got all the mole. But if you want to calculate the Kc, you have to change it into concentration, right? So and in the question it's 5 liter. So you have to change it into molar concentration. 0.78 divided by 5, you got this value. 0.33 divided by 5, you got this value. 0.51 divided by 5, you got this value. All right. So now you are going to do the Kc.